Right guys, this is my adventure into programming an accessory decoder. Now what led me to this? Well, as you know, the Z21 has the layout functions. You can design your layout on the Z21, compress the points change. Now currently I have a control panel. As you can see, I've got, these are what will be the point motor switches. Those lights here, they come on indicating which way the points are actually set. I've got a couple of normal switches here, I've got push to make switches here, and it's a control panel. Essentially underneath, these are where all the wiring looms for the layout go to. I've got two 25-pin sockets, two 9-pin sockets. So this is what I want to be able to use this, but I also want to be able to use the Z21 app. So this is what I currently have. So currently I have the control panel and the layout. The layout connects to the control panel. Right, my intentions are this. I'm going to have a control panel which is going to go to what you could call a black box or whatever. I'm actually going to build it in a toolbox. But essentially the toolbox is going to house lots of accessory decoders. So essentially what I'm doing, and of course that goes to the layout. So essentially this area here, I am hacking into the wiring that would normally go to the control panel. Now with that I have to think about how am I going to change the point motors using this as well as this. How am I going to replace switches? I've got my old push to make switches like that. I've got my on off dead switches like that. So I'm going to use relays. But before we get onto that, let's have a look at the accessory decoder. So this is what I've gone for. This is the LS-150. I think it's currently got another name now. This is an older model. And essentially the Lenz accessory decoders take 16 volts AC. Now why did I go 16 volts AC? Well, simply because the power from this is the same power that I use for my solenoid point motors. So, you know, why not? I have done some experiments in this. I tried the Gauge Master power supply, that gives about 1 amp. It was doing so much controls, it's no problem, but I could not get it to work with the actual point motors properly, as well as this. From a manual perspective, the electronic perspective, it wasn't tying in properly. So I've upgraded. I've now gone to a 3 amp 16 volt AC. So that's been part of the reason why we've had a little bit of a delay on this. So first thing I need to do is we need to program this up. Now programming's the easy part, but Z21, it's a little bit of a sod. What the Z21, and I'll show you some clips, this has been pointed out by various users, for some reason it adds a +4 on. In other words, if you do this on the Z21, you can program, say the first one was number 1, 2, 3, 4, 5, 6. You put this on another system, number 1 is actually 5, number 2 becomes 6, number 3 becomes 7, 8, 9 and 10. Well, if you've designed your little layout on your Z21, that's fine if you're using the Z21. But what if I wanted to use the DigiKeller's DR5000? And that is a thought I've got. I may go to that for the main layout. Numbers are going to be wrong. Well, there is a workaround, guys. And what you basically got to do is you've got to go into the maintenance tool on the Z21, and there's a little box on there that you tick, and it's called addressing according to RCN213. Tick that box, it sorts it out. This will then be 1. On any other system, it will still be 1. So that's brilliant. So I'll show you a clip of that and then we'll come back. Right then, this is the LS-150 that we're going to program. Now it's quite simple to program. What you essentially do is you push that button down till that colour's permanently on. Then you give it one push and you'll see it flashing once. That means we're at number 1. You then give it a decoder number and then it'll flash really fast. When it's flashed fast, you then have to give it its pulse time. Now its pulse time is divided by, max you can have is you put 100 in, that'll be 10 seconds. The least is if you put 1 in, that'll be 0.1 second. And the reason they do this is, if you have a slow action point motor, you may need to have that delay rate, say 3-4 seconds, and that'll enable a slow action motor to work. Obviously this is a solenoid one, so I just want to give it a sharp burst. So first thing I need to do is I need to set up some numbers. So we're going to go into control station, we're going to go plus, and I want some turnouts. So we'll have that one there. Not many. How many shall I have? I'll just keep banging them out. Doesn't matter what kind of point. Some more of those. So I need at least 6. Right, there we go. So I've got some numbers. What else shall I add? I know what I'm going to add. I'm going to add some push buttons. Now I'm going to use the universal push button. I will add another one of those. I don't want one of them. Right. Now then, I am going to go 101, 102, 103. And I'm going to go 176, 170 and 89. Just to show you that these can be programmed to whatever number. So let's do that one first. So let's select the point, select the pencil, and we'll delete that. I'll go 101. That's 101. That could be 102. So I'll crack on, get these numbered, and we'll come back. Right then, for my switches, this is a little bit different, this for the switches. This is a universal switch. So I'm going to call this side, I'm going to call that 170. And it's going to be a push button switch. And it stated 1 to 0, so that's good. Now then, this switch I'm also going to call 170. I'm going to make that a push button, and I'm going to change the state to 0. So what that means is I'll push 1 and it'll go on, I'll push 1, it goes off. Essentially like what a point does. That is what basically, if I push that it'll go one way, push it again it goes the other way. If I push that it'll go up, if I push the bottom one it'll go down. So essentially that is just like a point. And we'll just do this last one. This one we'll call 89. Make that a push button as well. Right, so those are going to be the numbers for each of these. Now I need to give it a delay time. So what you do now is you number this, but this is actually going to be your delay time. So I'm going to call this one, we'll go for 2. So that gives me 0.2. So that's good. So I'm going to use that as a delay time. I'm going to stick with that for everything. And that one we can simply bin. So that's all my things set up. So now I need to come out of that. We'll save that. Done. Right. So we'll go into the layout. So there they are. There's all my switches. So this is the beast. I'm going to press that and the light should come on. Magic. Light is on. Press it once. Now you notice it's just going boom, boom, boom. That's for position 1. So we're going to call that 101. So I give it one press and it's now flashing fast. This is where I put the pulse duration in, and it's going to be 0.2. Now you'll notice it's giving double flash. So we'll call that 102 and a pulse duration. So we're now on the third one. We're going to call that 103 and a pulse duration. Now the fourth one, this is 176. So number 4 is 176 and a pulse duration. So we're now on number 5. Notice I've got buttons here. This is 170. So it's accepted number 170. And there's my pulse duration. And this is number 6 now. 6, there you go, 6 flashes. That's took that address, that is 89, yeah. And a pulse duration. That's it, done. So now what you'll notice is if I press any of these now, that should have a little light on it. So let's have a look, shall we? See that little light come on? That means that has sent the signal to that, and away we go. Again, anything I press, notice the bottom one, that was your duration, no light. So there we go, that's the first step. So we're laughing fat apples now. Now, just before we come off this side is your DCC input, that's the bit from your track, from your controller. This side is the AC input, 16 volts AC. I'm using the 3 amp power supply for this one because I just felt I needed a bit more oomph. So the first problem, let's see if we can get a point working, shall we guys? So let's wire one up, crack on. Right then, just a quick reminder how a solenoid point motor works traditionally. I'm using AC, so I've got one common, goes to the 2 coils, the other wire, if it touches that side, it'll fire that way, If it touches that side, it fires that way. That's your basic solenoid wiring. Now then, you know me, I'm a little bit different. I've used a latching relay. Let me just pull out a little bit. Right, as you can see, I've wired this up in series, and what you'll notice is the blue will fire that way on that side. The blue will actually throw a magnetic switch in here, and it fires this switch up or down. So the blue goes down, yellow will go up, and this is what controls my frogs. So my frogs are controlled via this latching relay as well as a solenoid. So that's essentially what I currently have. So what am I intending to do? Well, it gets a bit more complicated now, guys. If you look here, got my solenoid, my latching relay, and now the feeds are coming through the accessory decoder. But you'll notice here I have still got AC supply feeding this switch, which will feed that and that. The idea is that is a mechanical switch, so I can do that on the control panel. That's the electronic switch, so that should fire it electronically. So let's get this beast wired up. Let's see what happens, shall we? Right then, so we're wired up as per the circuit diagram. So I've got my blue, grey, yellow wires now feeding into here. So, as we know, the grey's the common, that goes to the coil. We'll just have a little reminder. So the grey is that wire. Obviously the blue goes to the other side of the point motor, and the yellow to the other side of the point motor. So as you can see, if I switch, light changes. That's my latching relay module. So as you can see, it works. Right, let's have a look at the Z21. So this is currently on that, so that is 101. As you can see, it's working. Now did you notice there, guys? That point changed, the latching relay didn't. And this is an issue I've been having. Works up to now. There again, didn't change. Didn't change. Didn't change again. So it's not always changing. Well, that's going to be an issue. That really is going to be an issue for me. But we'll persevere and we'll work our way around it. So we'll put that to the side for now, guys. We're going to talk about some relays. So the first button I want to emulate is this. It's a push to make switch. We've all seen them. That's what I use currently on my control panel for 1 or 2 items. So I need to emulate that electronically. Now then, that's your symbol for your push to make switch. I'm going to use a relay, and it's a 12 volt relay, and essentially your 2 top pins are your coil, and these 3 pins and these 3 pins are the actual switch that moves inside. What happens is when the coil's energized, it'll fire the switch one way, and when you take the power away from the coil, it goes the other way. That is in basic terms what happens. So this is what I've got here. So in this case I'm calling it a normally closed circuit. So what will happen is, as soon as that energizes, it will come this way. As soon as the power's took away, it goes that way. Now, I'll be honest, I've had trouble with these. Unless you're mounting them to a board, they're a pain in the royal arse. And you have to put some form of diode protection on as well to protect the coil. Well, I've got an easy route. I found this. It's a PCB mounted relay. I've got my connections there just to wire straight in, connections out. So as you see on the out, I've got a common, a normally open, a normally closed. These are actually in the normally closed state, so when it activates, it'll flash over to the normally open. And I've got some wires here. I've got a diode going in, that'll be the common, a diode facing out, which will be an output on the LS-150. So we'll get that wired up and we'll see how that works. Right then, so we're wired up. So common back in C, my blue wire is in the plus. We're now connected to this relay board, and I've put a little battery LED tester. This is just to indicate that that switch is actually working on the end. So this is currently number 89. So we'll press that and see what happens. And there you go. As you can see, works as a push to make switch. And that is essentially what I've done. That is the circuit there. And that just shows you it going in, going out, and my little light working. Now, I showed resistor on there. You always need a resistor for your LEDs. My little LED test has a resistor built in, so I don't need to worry about that. Now then, how am I going to put that onto my control panel in the form of wiring it up? Well, it's simple. You wire them in parallel, sorry. So if that switch is down, current flows through. If that switch goes down, current goes through. So that's an easy hack. I can build that into my control system, no problem at all. Right then, what other switch do I need to emulate? Well, I need to emulate that. And that, of course, as you can guess, I'm going to use a latching relay. So let's take a quick look at the latching relay, shall we? You've seen this before, because it's what I use on my point motors. This is the board I've got. These are going to be the inputs from that, and of course it's going to output on the side. Nice and simple. So this is the intention I have. A normal latching relay will either be in one state, up or down. And that is basically an on-off switch. Nice and simple. That's how it works with an LED. So when it's down, the light will be on. If it's up, the light is off. We know all this because we've proven it already on the point motors. Not very reliable, I know, guys, but it has been proven. And this is how it gets wired up into the LS-150. Again, don't forget your diodes. I'm actually going to use some resistors on this purely because it's on its own. That's the only reason I'm going to use them. On the other one, remember, in essence, my point motor was acting as a resistor as well. And I have tried it with a resistor on the other one, didn't work for me. Without the resistor, it worked. On this, bit more protection, but always get your diodes the right way around. So there we go, that's what we're going to do. Let's crack on, wire that up, see that in action. Right then, so we have now got the latching relay wired up. And this is why I did two buttons on the actual Z21 app. One's to turn it one way, one's to turn it the other. So if I press this one, it turns on. If I press that one, it turns off. so I can turn it on, turn it off. And it's quite happy doing that all day long. Right then, so we know that bit works. Right, now then, the problem is, how do I wire this into my control elements? Well, if I do what I did last time, it doesn't quite work. Because that's me mechanical and that's me electronic. If that's down, yes, it sends light. If that goes down, it's still turned on. That goes up, still turned on. That goes up, it goes off. And as you can see, I've got a conflict of interest with the switches. So I cannot turn it off on one and turn it on the other. So, let's think of another way. We'll try the series way. Again, you can tell straight away that is not going to work. If they're both on, it'll work. If one of these goes off, goes off. So if I cannot turn it on, if that is in the off position, that switch will not turn it on and off. So that's not going to work either. So I had to have a little think about this, and this is what I came up with. It's easy when you think about it, guys. It's the lighting circuit technique. You actually wire your switch like this. So what you'll notice now, if that switch goes down, it'll turn off. If that switch goes down, it'll turn on. If that switch goes up, it's off. If that switch goes up, it comes back on again. So now I can turn it on and off either by the control panel or the electronic unit that I'm going to build. So that's a win-win. Took a while to think about that one, guys, but sometimes it's obvious and it stares you in the face. Right then, so we're now back to the point motor. Can I crack this point motor? And the answer is yes, I can. Point motors, essentially you can use it push to make to turn your point motor. I have created, as I've just shown, that can be a push to make switch. I've got two relays on there, I've got two switches on there, so why don't I use that? Now this, as you've seen, should do it itself, but it did not fire my frog properly. We saw there was occasions it was missing, and that is going to cause a short on your layout, a dead stop, game over, and it's going to be a pain in the ass. I need reliability. So this is essentially what I came up with. One push to make, the second push to make. One pushes the blue, one pushes the yellow, as you know. So that yellow would connect to that side, the blue connects to that side. So essentially all this unit is going to do now is control these relays. So essentially it's a bit of kit that's going to control relays. So that is my plan. Now it's not so easy to wire up, but this is the idea. I've got the common needs to come over, and those are my outputs. That wires up to where the mechanical switch is. On the inputs from the LS-150, the common is going to be grey. Now watch, the diodes are feeding in, and my outs is the yellow and the blue. Now you may notice that now and again I've used an orange wire. It's simply because I ran out of yellow. So in some cases there's orange, in some cases there's yellow. It's just that simple, guys. But that essentially is what we're gonna make. Now those that are really ambitious, that is the circuit diagram, guys. It's not pretty, it's not friendly, but it shows the accessory decoder, it shows the relays, the powering goes back to the mechanical switch, it shows the power feeding the switch, the power feeding that, shows will be common, feeding the relays will be common, essentially feeding the latching relay, and that is the power to the frogs, which I'm simulating with an LED just to show you that it switches. It's not pretty, I know. I couldn't really decide how to draw it any easier, so that is what I came up with, guys. So last roll of the dice, let's wire this up and we'll see if it works. Alright guys, back again. It's all wired up. Doesn't look pretty, but wiring never does. Yet to be refined. But my relays wired up now. They'll push to make configuration. So hopefully this should power them. In turn will power that. And we're going to have to check this and see if we've got any light issues. We'll turn the light off so you can see the LED a bit better. Right, let's see what happens. So that's my normal switch. So that's what's on my control panel. Happy days with that. And let's try the actual point motor on the accessory decoder. And it works. I have got no issues at all. Just bringing the light back on. There we go. It works. It's not pretty, but it works. So there we go. That's the proofing concept. I may refine this circuit a little bit more. I'm not sure. I may need to add a few resistors in there yet. It's all going to be trial and error for me. It's going to be a while till I actually build this, but once I do, it'll be nice. It's going to be for the main layout. It's something I'm going to build off camera, and it'll just turn up in an update somewhere. It's not going to be built for many months. This is just me messing around, seeing what parts I'm going to need, get things together. But this is going to be way down the line. I've got a lot more projects to do. I want to crack on now with Sway's Pond. I want to get that further, try and get that more into a finished state. I've got lots of other projects, and of course my advent calendar, that'll be coming soon for those people that have been following me a long while. That will be again happening in December, so I've got to crack on with that as well. So December's a busy month for me, but lots of content to come, and of course I'll still be chucking out other videos as well. So there you go guys, that's my experience with the LS-150 from Lenz, my little trial and tribulations, how to use different relays in different configurations, and how I'm going to use it. So hopefully that makes a bit more sense to you, and we'll catch you in the next one guys. So bye for now.